And then I'll have to talk to my computer again by myself, which is way boringer. Let me get the screen share going because then it really doesn't count. I have a little Excel sheet that I built here that I'd like to do as a means of reviewing model specification for time varying predictors, how you set it up, and what you get back in return. And so I'd like us to do a little review by building this together, if you don't mind. That work for everybody? Rhetorical question, but. So I have my two ways of setting up the level 1 predictor model here. So I want to make that point. The distinctions about centering apply to your time varying level 1 predictor only. There is no distinction at level 2. You have to center at a constant because there is no higher level variable. That would make sense. So if I do what I would call variable centering as a more general term, or person mean centering in this context, how do I make my level 1 predictor? Like if you were typing in R or stata, what would you type here to make a new variable?
Minus mean.
Yeah, so I have xti generically minus, and I'm going to go pmx like that since I can't do x's with bars over them very easily here. Pmxi. Very good. And at level 2, what would I do? And I will post this after class, by the way, if you want. What's this one? You can talk or you can type in the chat. Either way is good.
The between Mersenne, yep. Between person.
Between Mersenne, yep, gotcha. Followed that one. And do I need to do anything else? Yeah, minus, I called it C2. So it does not matter what constant you pick. It just, 0 needs to mean something so that everything else makes sense the same way as usual. So fixed intercepts make sense, simple slopes of interacting predictors make sense, and so forth. So this is what my variables would look like. So then this part of it here, the question is, what do I get back? So if I put in the level 1 predictor only, how would I interpret its slope? And your choices are within, between, contextual, or smushed. Those are your 4 choices. So if I do person mean centering and I put the level 1 predictor in all by itself, what do I get back?
Within.
That's within. Okay. What am I assuming about the effect of the person mean predictor at level 2 then?
Time invariant.
It is time invariant, but if I don't put it in, what am I assuming about it? The act of omitting a predictor. We got
constant?
We got 1 vote for constant, 1 vote for within. Same as within, that's another vote. I'm still waiting for the right answer though. Good thing we're doing a review. This stuff is tricky. It's very tricky. That's why I have a job.
Would it be contextual?
Nope.
No.
So I should say the 5th choice would be that it's 0, I guess. That one doesn't have a name. Does that help?
0.
0.
Yeah, that's what it is. So, yes, if I leave it out, then I'm saying that slope would be 0, the same as any left out slope that you're used to thinking about. What if I put in the level 2 predictor only? Then what do I get? Within, between, contextual, or smushed? Everyone's scared to answer now.
But what's the cell, Lisa?
This
C5?
cell? This is the effect of the level 2 predictor when it's all by itself. That's where I'm at. Yep.
That
C5.
would be between only, right?
Yep, that is. And what am I assuming about the within slope if I don't
0.
put it in the model? It's 0. Yep.
All right. Okay.
And if I put them both in at the same time, what does the level 1 slope become?
Contextual?
Not this one. We got 2 votes for within, 1 vote for contextual. Yeah, this one is within. And if I put the level 2 with it, what does it become? Yep, between. And this summarizes why I like this way. You know what you get. I find that comforting. Now the other way. This is the tricky way. So if I do constant centering, what does my level 1 predictor look like? I'll start off with the same xti minus what? Yeah, I called this C1 in the notes because it doesn't have to be the same constant. Doesn't matter what it is. So if you leave your predictor uncentered, let's say it's a binary variable and 0 versus 1 already means something to you, fine. You can subtract 0 and leave it uncentered. Doesn't matter. How about at level 2? What goes here? Person mean x underscore I minus C2. Same. So these two here, those are the same. Same variable at level 2. The difference is what happens at level 1. So now, if I put in my level 1 predictor without its level 2 person mean counterpart, what do I get? Within, between, contextual, or smushed? One vote for conflated. Conflated is a synonym of which of those 4 choices?
Smush.
Smushed, yeah. It's my class, it's going to be smushed. You want to write conflated in your papers so that you don't sound silly, by all means. But I will tell you that smushed is starting to become a thing. I have seen a couple different papers that use that term, and one actually had it in like a subheading, like of smushed effects, and I was like, yeah, I made that happen. Now, if I leave out the level 2 predictor, what am I assuming that it is? Yeah, within, between, conflated, or smushed as well. So I'm going to put it in parentheses here. That's what it would be. I'm going to put these in parentheses as well, so it makes more sense. There we go. And that one, and that one. Okay. So yeah, that is what a smushed effect means, is that if you put it only in level 1, you are assuming that the level 2 effect is the same, even though it's not in the model. The one variable is trying to do the work of 2 predictors simultaneously with 1 slope.
Lisa,
Yes.
I have a question related to this because we have seen that the smush effect, it is a weighted combination of
Yes.
the level 1 and level 2.
Yes.
Is that the same that assuming both effects are the same number?
The smushed effect is neither the within nor the between, but a weighted combination, just like you said. But it would be the same weighted combination at both levels.
Okay, gotcha. Thank you.
Yeah, it's neither. It really is. And this is where the term came from, is because I used to make this hand gesture of things being smushed together. And that's where it started. So yeah, you are saying that the same coefficient essentially would multiply both the within part and the between part to get you a predicted outcome. And that coefficient is a weighted combination. Most of the time, it's going to be much closer to within because you have more occasions than you have people. That's not necessarily the case. And say in maybe dyadic data, if you only have 2 people per cluster, the smushed effect is going to be closer to a 50-50 split because of the number of people versus the number of couples. Dyads, I should say. How about if I put in the level 2 predictor only? Then its effect is within, between, contextual, or smushed. We got 1 vote for contextual. If it's the only one in the model. What's your vote?
I was gonna say contextual, but then I thought about smushed. I get confused about contextual a little bit.
Yes, join the club. That's why we're going over this. It is really confusing. Yes, okay, we got a couple more votes for contextual or smushed. We got 1 vote for between. Yeah, it's this one. It's the exact same. Because if there's nothing in at level 1, then it's just the level 2 person mean by itself. It's between. And you're assuming that the within effect is 0 if there's no level 1 predictor. Now the combination case. If I put them both together, my level 1 slope becomes within, between, contextual, or smushed. Couple votes for within, that is correct. So the reason that it becomes within is because you have statistically controlled for the contribution of the person mean via the inclusion of the level 2 predictor. So then the unique part of the level 1 predictor is just its within information. Therefore, that unique part carries a within slope. Now, what's the level 2 slope? What does it become? Same 4 choices. Got 1 vote for contextual, 2 votes for contextual.
I'm going with contextual.
It is, we got it. Contextual finally is on the board here. Yeah. So we end up at the same place so long as these effects are fixed only, because what I can say to unite them is that within plus contextual, nope, can't spell. Within plus contextual equals between. Alternatively, between minus within equals contextual. Now the difference in interpretation. Between and contextual are both level 2 effects of the person mean. The difference is that the between effect is not controlling for the actual value of the level 1 predictor, whereas the contextual effect is.
Can you say that again, please?
I would love to. Between and contextual are both level 2 slopes. They each apply to the person mean same variable, but they differ in what they mean. Between is not controlling for the original value of the level 1 predictor, and contextual is controlling for the original value of the level 1 predictor. In longitudinal data, contextual to me is much less useful because controlling for the occasion doesn't make sense in the fact that occasions are not separate entities with their own characteristics. In clustered data, so like, we do the math in my head, like 7 months from now, I'm going to be singing a different tune. In cluster data, where I have individuals nested in clusters, the contextual effect is, what is the influence of the group above and beyond your own value of that predictor? What is the influence of the group after controlling for the individual? That makes a lot more sense. After controlling for the occasion, I don't know what to do with that. So the constant centering version, to me, is much easier to screw up because you have to know what it's paired with to make sure that you haven't created a smushed effect accidentally. And this is a very, very well-known problem. I think the first paper that really laid this out and got cited was maybe 1995 or so. It's been covered to death in tutorials, but what is not often appreciated by the same people writing the tutorials is that this concept applies to interaction terms beyond just main effects. And that's where the algebra was that I told you we would hold off on, which we have now get a chance to talk about today. So, any questions or things you want me to repeat about this?
Yeah, Lisa, I had a question. I mean, it may be more about like adding columns to this table here.
Okay.
How does this change with maximum likelihood and Bayes estimation and M plus? Because I know that it's sort of like just flips in some of these cases.
Okay, that story of what happens in M plus with respect to ML versus Bayes depends on whether you're at this point. So let me back up. At this point, all we've talked about are fixed effects, not random effects. So where the ambiguity comes in M plus is when you set up placeholder syntax to allow you the potential to also have a random effect and or a cross-level interaction. That's where the ambiguity comes in. In M plus, if you ask for a level 1 fixed effect, it is going to be the within effect either in Bayes or ML estimation. What you get at level 2 depends on the type of level 1 predictor that you have. If you let M plus do the centering for you, so we haven't seen an example of that, that's coming in 4B, and you only ask for a level 1 fixed effect, it is going to be the within effect in ML or Bayes. If you use the placeholder syntax, then it will be within and contextual if you're in ML, or within and between if you're in Bayes.
Okay, got it.
Yeah.
Thank you.
I have a whole example about this, folks. So if most of that was word salad to you, no problem. We're going to get there. I understand. But this is the beginning of the idea of what you get. You have to understand how your software is working very well to be able to fully appreciate this. And so doing person mean centering gives you, I think, more control because you're setting up the variables to only contain level specific information in the first place. So you know what the consequences of them is going to be because you set them up that way. In constant centering, you're relying on statistical partialing, that's the right word, with the T, right? Partialing, holding constant, controlling for, all those words, partialing. Did I say it wrong again? Anyway, I need more Mountain Dew, sorry. I gotta reload here. Oh, level 1 predictors requires more than Mountain Dew. I think I need to switch to something stronger. Maybe some cocaine or something to get me through the day. No? Heroin? No?
Lisa,
Yes?
you're wild today.
I know.
Wild.
I know. I'm out of control in my basement here. All right. I've been cooped up in the house too much. I think that's the problem. I'm actually getting out of my basement tomorrow. I have to come to campus for a faculty meeting. So woohoo, party time. And I'll be coming to ProSem as well. All right. Okay, gonna save this. We're gonna talk about interaction terms then as a precursor to what happens in our example. So I'm on slide, let's see here, 28, that's where I am. We're talking about interactions involving time-varying predictors. So the idea of moderation. So if I have my story here, for instance, if I have time-varying stress predicting severity, so the pictures that I went with, and I have some kind of between group moderator. So people are in different groups at level 2. So if I do person mean centering, then I would potentially have 2 different interactions. The within person effect of the within person X variable, so that would be within person stress times group, and then the person mean variable times group. So this would be set up the same way that we just looked at in terms of within person X is X at each occasion minus the person mean. Person mean X would be centered at a constant so that 0 means something. So if I get this back, then the moderation that I'm asking about is level specific. So the group by within person X interaction would tell me the extent to which the level 1 within stress slope differs across groups. The person mean X by group interaction is a level 2 interaction. So the first one within person X by group is cross level because it's level 1 by level 2. The second one is a totally level 2 interaction. This would ask whether the between stress slope varies by group. So we looked at an example of this in the context of person mean negative mood being moderated by binary gender and predicting glucose. We did that last week, I think. So if I forget this level 2 interaction, if I forget it or it's 0 and I decide to take it out, then what's left is that I'm saying that group moderates the within slope only and group does not moderate the between slope. There's nothing wrong with that. It's a little bit weird to me to leave it out because you're talking about the effect of more stress than usual, and what usual isn't part of the story then in terms of the moderation. So I would be inclined to leave in a non-significant level 2 interaction for clarity of interpretation, and to make the point that it's not a between moderation, it's a within moderation. But there's nothing wrong like with leaving either of these out. You're just assuming that that moderation coefficient would be 0. Okay, with me so far? Now, if I go the other way, I'm asking whether the within slope varies by group in the cross-level interaction, and at level 2, I'm asking if the contextual level 2 slope varies by group, not between, but contextual. And so that implies that if I forget this level 2 interaction and I just have time varying x minus a constant times group, that is a smushed interaction. So the exact same logic that we just went through with the table applies if I'm not talking about a main effect, but I'm talking about an interaction term. The cross-level interaction, if I don't have the between analog to it, is going to assume that group moderates the within slope to the same extent that group moderates the between slope at level 2. It's a smushed interaction coefficient. So anything that I potentially want to interact with time varying x, I have to have the analog to that interaction with person mean x also. Everywhere that you would see time varying x in an interaction, person mean x also has to be there. Otherwise, the cross-level interaction is smushed and you're assuming equal moderation of the slope at the within level as at the between level. Okay, does that make sense so far? Maybe, yes, okay. Here's the algebra that proves it. So I've written out the same model using person mean centering and using constant centering, get to a composite form of each, and then rearrange the terms until I can write one and so that it is analogous to the other. So the conversion back and forth is given on the bottom here, and there's a lot of text in chapter 8 focusing on this idea. So as long as you have the corresponding level 2 interaction with the person mean, then you can pull apart moderation of the within slope, moderation of the between slope, and then figure out what moderation of the contextual slope would be, or vice versa, because they're linear combinations of each other. Intra-variable interactions work the same way. So do you remember at the beginning of the semester when we talked about age and cohort? Remember that nonsense, messiness? As this. Because cohort was age at the beginning of the study. So essentially what that model was fitting, was the analog to that, is the within person x interacting with person mean x, what I call an intra-variable interaction. So you can fit an interaction between the two parts. So for instance, if I had stress measured daily and I had person mean stress and I put an interaction in the model, if I have used person mean centering, that interaction is going to tell me if the effect of more stress than usual depends on how much stress I tend to have. That seems like a very reasonable thing. Like if we all know people who tend to blow things out of proportion, right? If you don't have a lot of like trauma or worry in your life, then having more than usual, it's like, what? Whereas if you're a graduate student and you're trying to balance 8 million things at the same time while being poor, it's like, what's one more thing? I can handle this. It's fine. I got a whole 4 hours of sleep last night. I'm feeling good. So how the effect of more than usual depends on how much you usually have. That is the idea of an intra-variable interaction. You can do that. What gets trickier though is figuring out what else you have to have in the model, because it seems like that would be enough. So if I did something like this, and I'm using color to try to make the point that I'm thinking of person mean x as like any other kind of level 2 moderator, so I put it in the same pink font that I had grouped before. Within person x times person mean x is, does the effect of more stress than usual depend on how much stress you tend to have? The other one, though, is also possible. And so this is the moderation of the between slope by person mean stress. And if you look at this, it's like, wait, that's a quadratic slope. So this is allowing the effect of more stress than other people to depend on how much stress you usually have. And that results in creating a quadratic coefficient by which the between slope can speed up or slow down, depending on where you are on the between slope. And so this is the reason why we had age cohort squared in those models at the beginning of the year, is because we want to be able to differentiate moderation by cohort at the within level and at the between level. So if I were to do constant centering, that is the age as time model. So if I have time varying age, for instance, times age cohort, that interaction is smushed if I don't also include cohort by cohort, the level 2 analog to that. So the person mean centering model is analogous to using time and study as your level 1 slope, and then looking at age at baseline as a level 2 moderator. The constant centering is analogous to using time varying age and still adding age at cohort to control for contextual effects. But this is why the quadratic term shows up, is to unsmush the cross-level interaction. Here's algebra. Here's how you get back and forth across the two solutions. Chapter 8 refers to this type of setup as well. So here's where the equivalency stops. What if I want a random level 1 slope? Can I do that? Can I have a random level 1 slope?
Is that the interrobang thing?
Yeah, that's where I'm going. That's where I'm going. So let me ask you the first question, because this is a softball question. Actually, this is a t-ball question. I decided to use this analogy in my other class, and I'm going to stick with it. So t-ball is where there's like a little pole with a spot on the end of it, and there's a ball, and that's your first type of baseball as a child that you play, is to play t-ball. You hit it off the pole. So this is the t-ball question first. Can I have a random effect of my level 1 predictor slope? Sure, I can. That was like one of the first things we did, right? The idea that each person needs their own slope. So in this context, if I'm not talking about everyone needing their own time slope, what I'm talking about is everyone needing their own, say, stress slope. Maybe the effect on health of more stress than usual varies across people. Sure, that seems like a reasonable thing. And I can have a random slope of a level 1 predictor over level 2 units. So your slope can be random at the higher levels of the model if you have them. If I had people nested in groups, I could have a random slope across people and simultaneously across groups at the same time. That seems fine. But now the question is, what variable is my random slope going to multiply? So in the person mean-centered model, I have my U1 term here. And if I do the math to fill in the placeholders, I have my U1 term multiplying original x minus the person mean. So the U1 random slope is only applying to the within person part of my time varying predictor, because that's how I set it up. So I call this within person x, this abbreviation here, but I've written it out to make a point. Whereas if I use constant centering, my U1 random slope applies to all of x, not just the within part. In other words, I'm assuming that the random slope applies equally to the within part as to the between part, because they're both buried in this time varying predictor still. So that distinction creates the potential for slope smushing on the random side as well, not just the fixed side. So we can't as easily add a contextual effect as a random slope, because what that amounts to is asking for a random slope of a level 2 predictor across level 2 units, which is like the first thing that when you learn random slopes, you're told is not allowed and is not possible. Technically it is. I've been lying to you, but I did it with good intentions. So that is the interrobang thing. that we talked about in that unit, where we were discussing whether we should have age as having a random slope or time having a random slope. So if we're using the person mean centering strategy, we don't have to worry about random slope smushing, because the random slope is only going to apply to the within part of the variable, because that's how we set up the variable in the first place. So back to, one second here, it would be like the smush chart. We're right there, but we're talking about a random slope. If all I have is a random slope for the within part of the variable, then I'm talking about between person differences in the within person slope specifically, and all is good. But if I have my random slope here instead, then I'm talking about not just between person differences in my within person slope, but between person differences in my between person slope at the same time. Now that's not really a thing when in terms of slope variance. The way to think about that is internet heterogeneity of variance. Intercept, excuse me. I told you I need some heroin. This is not going well. Okay, go back. Where did it go? Where was I? This one. Okay, there we go. Slide 35. So there is a paper on your reading list that was just accepted for publication by myself. So I don't have, it's not actually out on the internet yet, or else I'd give you the reference to it. But it's going to be published in NBR, and they did the algebra, the simulation, and the example to demonstrate all of this. They did it in a generic context, not longitudinal, and so this is my translation into it. So if you use within person X as the variable that gets the random slope, so you use person mean centering, you put within person X in the random part of the code and in the fixed part of the code, there's no problem, because you are assuming within person slope as like the unit of analysis that's been given the random effect. So between person differences and with the within person slope, done and done. Behind the scenes though, do you remember what we used to talk about in terms of the implied variance and covariance over time when we add time slopes? Remember this? So if I have a random intercept only in my growth model, what kind of pattern am I predicting with respect to variance and covariance over time if I only have a random intercept? Constant. There's the vocabulary word that goes with it, 2-word phrase, 1 word starts with a C. Compound symmetry, yep. A random intercept only induces covariance of occasions from the same person, but it's constant. And it splits the variance into within person residual and between person random intercept, but the sum of those is constant. What happened when we added a random linear time slope? When we added a random linear time slope, how did that change the predicted pattern of variance and covariance over time? The V matrix is what I'm talking about. What does it look like? It's not constant anymore, not compound symmetry anymore.
Unstructured? No.
Not unstructured, but it's trying to approximate what unstructured would be. Heterogeneous, yeah, or not constant. And it's not constant as a particular type of function. So if you add a random linear time slope, what you're saying is that the variance in total across time follows a quadratic pattern, because the prediction has time squared in it. So the variance across people is going to form like a U, where at some point it's a minimum, and as you move away from that, the variance increases because people spread out from each other as they change differently. And the covariance between any two occasions depends on which two occasions those are. So it's still a function in the sense that you can predict what the variance would be for any value of time, observed or not, but it's a heterogeneous variance function. Well, if I swap out the word time from everything I just said and put in time varying predictor instead, it's exactly the same. So what I'm doing if I allow a random slope for my time varying predictor is I'm saying people need their own effect of more than usual, and that then creates heterogeneity of variance in the same quadratic pattern as what we had for time. So now there would be heterogeneity of variance across within person stress in the same quadratic pattern. Different slopes spread people out. So that much is not a problem. That's a consequence of adding a random slope. But if I put in a random slope for a constant centered predictor instead, then what I'm doing is saying that the extent of that quadratic heterogeneity of variance across X happens equally to the level 1 part of X as it does to the level 2 part. So it's creating heteroscedasticity of the intercept at level 2 at the same time. And to the extent that the data don't like that, then the coefficient that you get back for the random slope variance is going to be wrong. It's going to be some mixture of whatever it should have been at level 2 and whatever it should have been based on level 1. So it's smushed. It's the same problem. But it's a lot harder to add the contextual random slope. I have tried to do this in a couple different data sets, and I finally got one to estimate the other day, and I was so excited. I made it work finally, but I have not been able to do that. So that contextual random slope, the idea that you could have a level 2 predictor have a level 2 slope, the notation in the multi-level model world has not anticipated that. So that's where the interrobang thing came from, because I just gave up trying to figure out what it should be, and I made it my own letter. Interrobang is the question mark with an exclamation point through it that is like the WTF symbol. So if you are going to have random slopes in your model, then you pretty much should be using person mean centering if you're going to use observed variables. The alternative is latent centering, where the program in a multivariate context divvies up the time varying predictor into its level 2 and level 1 parts as latent variables the same way it does for the outcome. Then you just have to make sure that the random slope is applying to the within part only and not the total of the variable put back together again. Okay, 111. How are we doing, folks? Questions so far? We did figure out, by the way, in the other class that there are thumbs down signs now in Zoom, as well as something that looks like a thumb sideways, which is like a pointy finger. So, yep, exactly. So, point of the story, bottom line, if you're going to have random slopes, person mean center them. Even if the rest of your model is set up to have within contextual because you want it that way for some reason, the slope that gets the random part applied to it can be different. So like in R code or in Stata code, right, there's where you list the fixed effects, and then there's the part in parentheses where you list the random effects. Those can be different variables. You can put a person mean centered variable in the random side and put a constant centered variable in the fixed side if you want within contextual instead of within between. That's allowed. What about categorical predictors? So if I have a binary variable at level 1, am I home free, or do I need to worry about this stuff all the same? That's like coach pitch, not quite T-ball. Sad face. Do I need to worry about this? That's your worry face. Oh, good. Okay. Yeah, you do need to worry about this. And this is another thing that's not well understood, is because all of the examples that you see in tutorials and in the literature feature some kind of continuous variable where the idea of centering it and talking about like 1 unit more than the mean or all of that stuff makes sense. But on the surface of it, you would think, well, if it's just 0 or 1, then do I need to do any centering? Like, can I just throw that in? Nope. You don't have to person mean center it, and I agree that that's weird. So, for instance, if I have a 0, 1 variable, and the person mean for that variable is 0.4 across occasions, and I do person mean centering, then I've taken my 0 or 1 variable and I've turned it into minus 0.4 or plus 6, depending on whether I have a 0 or a 1. And that's weird, right? We can all agree that that's weird. But it's okay, though, because the difference between minus 0.4 and positive 0.6 is still 1. And that's what the model is responding to. It's a 1-unit difference still. So the starting and the ending points are inconsequential to it being a 1-unit difference. But it does make it weird to think about an intercept, because the intercept is the expected value when x is 0, which under this centering scheme cannot happen. So I agree that it's weird to think about it. So if you are going to keep your binary predictor the way it is, when you put it in the model, you are creating a within contextual situation. If you want the between effect instead of contextual, add them together as a linear combination. So you can leave it as a binary variable for the fixed effect and have within contextual. You would still need to person mean center it, though, to have a random slope for the same reasons. However, not all binary variables make sense in terms of how to think about the level 2 representation of it as a person mean. So if I have a binary variable that reflects something that's transient, like, did I get in a fight with Huey today? And I answer that question every day of the week, right? You could compute the proportion of days in which I fought with my 8-year-old son. Like, you could compute that. And maybe you could use that as a basis for making some sort of judgment about how well we get along in general or something. Or you could just assume that he's 8 and we're going to get in a fight about something every day. Other types of binary variables reflect like changes in status that can't be undone. So in the data set that we used for the age cohort stuff, the Octo data set, there is a binary variable for whether or not someone has been diagnosed with dementia at each occasion. So people who are eventually going to get diagnosed would be like 001, 11111, because you can't undo that once it happens. So the idea of person mean dementia doesn't really make sense, because it's like, what proportion of the time did you have dementia? Well, it didn't just start all of a sudden. Like, it was, you could see it coming from ahead of time. So for something like that, I would think about different kinds of people. So for this example, rather than come up with a person mean at level 2, what I would do probably is do they ever have it or not? Because odds are good, the people who are on their way to a diagnosis look different, but even before it happened, than the people who were never going to be diagnosed. And logically speaking, if you have somebody who is at a 0 the whole time, they cannot show a within person effect. You don't have the before and after if they never had a diagnosis. So then the idea of a within person effect is a nested effect only available in the people for whom it can be observed. So you then would still have the binary 0, 1 at each occasion in addition, and that becomes like an acute shift in the trajectory. So people who are eventually going to be diagnosed are allowed to differ the whole time from people who are not. Like, you can think of just different trajectories for different kinds of people, but then on the trajectory you can have almost like a piecewise function where there's a drop at the point of diagnosis, and then they might be on a different slope after that. So you can have both chronic and acute. This isn't a clean between within kind of separation anymore, but I would argue that it makes more sense. So you would want to think about whether your binary variable is a transient kind of thing or whether it reflects a fundamental change in status. Other examples that I had from previous students asking questions, things like mentoring in children who are at risk for something. So there was one student who was looking to do analyses related to the effect of having a mentor in a student's life and before and after the mentor came along. But some of the students changed mentors. And it turned out that that was not a random subsample. There were some people who were harder to work with and the mentor would quit and they'd have to get a new one. So it's not just like, do you have one right now? But are you the kind of kid who's going to cycle through mentors as a personality level kind of thing? So you might quantify like somebody who never had a mentor as one option, somebody who always had a mentor as another, and somebody who switched or had, something that's more transient as like 3 types of people at level 2. And you can distinguish person level trajectories across the types of people, and then within level 1, the before and after kinds of coding. Same thing with someone else was looking at the effect of families where they had, it was traditional 2-parent families and heterosexual couples where they were looking at like whether or not there was a father present in the home. And there were some families that always had a dad, some families that never had a dad, some families that had a dad and lost him, some families gained a dad, and so forth. So if you think about like kinds of families as a level 2 categorical predictor, then at level 1, you can look at within family changes, but they only logically apply to families that had a change. Like the families that always had a dad or never had a dad, you can't show the before and after. Another one is like whether or not you work night shifts. People who sometimes have to work nights are probably different than people who never do. So that's another type of, think about the type of person at level 2 and maybe have a different type of coding scheme for that, not just person being centering for everything. There was a tutorial that is online, and so I have a link to where that is. I thought this was very well done, and I would recommend reading this because they cover not just dummy coding schemes, but also effect coding schemes, categorical predictors with more than 2 levels. What it boils down to is that let's say that you have a 4-category variable at level 1. So back to regression, back to softball land here. If I have a grouping variable with 4 categories, how many slopes do I need to distinguish those 4 categories? 3. Okay, so how many different person means am I going to need? 3. I need the person mean for each dummy code to go into the level 2 model. So the ideas are the same, but it gets to be a little more complicated to keep track of what this stuff means. All right, question.
Yeah, so if we have a variable that we know that some people at level 2 won't have like effect for that variable, the coefficient for that group would be 0.
You don't necessarily have to set up the level 1 effect as a nested effect in the syntax. That's what's going to happen. But it's in terms of the inference. Logically speaking, you can only talk about, within person change in people who ever change status. So it's more about like the inference that you're trying to make, I think. You don't have to set it up that way. So long as they have a 0, then there's no way that an increment can apply to their score. Like if they never had a 1, then there's no change in the prediction. Does that answer your
Okay.
question, or am I off track?
I'm
You can
not
be
sure.
honest.
Yeah,
Like, no.
I understood what you said, but my question is not fixing the level 1 value. But for example, if we are working with people who smoke, we
Okay.
have people who don't smoke and they will have 0
Mhm.
in the level 1 variable, but at level 2 we can use some kind of variable that divides between smokers and we will have variation in that group, but we can also have non-smokers, right?
Yes.
In that case, within non-smokers, the effect that we assume would be 0 or can vary. I'm assuming would be 0, right?
Yeah, if somebody is, if the time varying predictor is whether or not you smoke today, and you have a non-smoker who never smoked at all, then they cannot show an effect of whether you smoke today. Like,
Yeah.
so like logically, you're talking about what is the influence of smoking this day and not the other day in smokers, like in people who smoked at least once. For something like that, if you're going to use a person mean, you don't necessarily have to assume it has a linear effect. So let's say that I have a 5-day study. The only possible values for a person mean of a binary variable would be like, 0, 0.2, 0.4, 0.6, 0.8. You don't have to draw a linear slope through that. Like you can treat that as a categorical variable to look at whether there's like a big jump from going from 0 to something and maybe a lesser jump amongst the 0.2, 0.4, 0.6. So you're limited only by your own creativity, I think, in this case.
Thank you, Lisa.
You're welcome. Maybe I don't need the heroin after all. We'll see. Oh, good. We're at a summary slide. That always makes me happy. Other questions? All right, so this is what we've covered so far. Person mean centering versus constant centering. Let me pull up, this is the remainder of example 4a, which is, I'm guessing, what we'll end up with today. So that we started talking
Lisa?
about this last time. Yes.
Sorry, I have a quick question because in chapter 8, almost at the end, you talk about the role of time varying predictors as predictors of heterogeneity of variance.
Oh,
But
location scale stuff.
yes, exactly.
Mhm.
But you have not included content related to that in this set of slides. Are you planning to explain that a little bit, or that's related to the textbook only?
If I have time, I'm planning to explain it. So where I was going to put that was going to be, I had a unit titled something like intensive longitudinal data, and I wanted to do at least one example within that of what he's talking about. So the question was, at the end of chapter 7 and at the end of chapter 8, I have an extension of into what is known as location scale models. Those are models for predicting heterogeneity of variance as an outcome. So for instance, in this context, some people may vary more than each other in their glucose over time. Like some people may just have more inconsistency in their outcome. That idea of individual differences and inconsistency can be operationalized by thinking about residual variance as a per person variable and then estimating what is known as a random intercept for the scale model predicting it. So that would be a second kind of random intercept that allows individual differences in within person inconsistency. So I got to do the gestures for this one. Like fluctuation, like some people don't change very much across time and some people are all over the place. That idea of an individual differences in the extent of fluctuation, that's what location scale models are designed to predict. And at the time I wrote the book, trying to estimate them was very difficult because you had to write your own stuff. Like, so I used NL mixed in SAS, which is, it's kind of like Stan except not Bayes, like where you write out the model and you list all the parameters and you have complete control over everything. Since then, there's been more advances in software, including dedicated software that Don Hedeker has created to do this because he's kind of the go-to on these models. But as of M+ version 8, they have it in there. And so the way they've operationalized it is that you can allow those kinds of heterogeneity coefficients, not just on the outcome side, but on the predictor side. So the extent of individual differences and inconsistency can predict other stuff. And so I wanted to tackle that topic within that context of a multivariate framework, because then you have more flexibility in how you apply the location scale model, not just to the Y side and univariate software, but to an X side potentially at the same time.
Thank you.
Okay, other questions? All right, then let me show you a few last things here and we will call it a week. So we started looking at this last time. This is part 3 of the handout, switching to a constant centering approach, or grand mean centering as it is also known. I like the term constant centering better because it emphasizes the fact that it doesn't need to be the grand mean. There's nothing special about the grand mean as a centering constant that you have to use. It doesn't really matter in terms of the information a variable contains. So we did look at the first model last time, but just to review, I am looking at an analysis predicting daily glucose from daily negative mood, and daily negative mood still has its level 1 and level 2 parts in it. So just adding one fixed effect here. And as you can tell from the name of the object in R, this is the smushed model. So in terms of interpreting this fixed effect, this slope of 0.012 is neither the within slope nor the between slope, but a weighted combination of them both. And I I just added this today since I was looking for that last time. A comparison with the within slope shows that it is pretty much the same. It's just a tiny bit higher. The problem with leaving this model the way that it is not so much in level 1, because it's pretty close. It'll give you a decent approximation of within. The problem comes in level 2. So we're assuming that the between slope is also 0.012, and I know that it's not. It's actually much stronger. So in practice, there are 2 ways that you can tell that someone has created a smushed effect, even if they don't recognize it. In the table of their results, if they do not have some reference to the same variable included at level 1 also at level 2, and their text did not describe any kind of person mean centering or latent centering to remove that level 2 variance, it's a smushed effect. Once you start looking for this, you will see it everywhere. Even in well-meaning tutorials, sometimes you will see it. The other way that you can tell is if they describe variance accounted for across models, and you can see a change in the level 2 random intercept variance, even though they don't have a level 2 predictor. That means the level 2 part of the predictor with the smushed effect is responsible for that change in variance at level 2. Level 1 predictors cannot account for level 2 variance. It doesn't work. It's the level 2 variance in the level 2 predictor, the level 1 predictor that's doing it. So this model accounted for a tiny bit of the residual variance at level 1 like we anticipated, but it also accounted for level 2 random intercept variance. Once I fix it by adding in the person mean negative mood, then we're in the within contextual space instead. So directly what I get is the within effect, I directly get the contextual effect, and the between effect is the 2 of them added back together again. So now the output is going to tell me the within slope. So there's the 0.011. We had the exact same result when we did person mean centering. The effect of the person mean is not between, it's contextual. So the way I would talk about this is after controlling for how grumpy I am today, for every unit grumpier I am than other people, my whole mean glucose goes up by 0.6. After controlling for today is the key thing that makes contextual different. Between is not controlling for today, contextual is controlling for today. If I take the 0.01 and add the 0.06 to it, then I get my between back. So those are the 3 coefficients that I would have in total. And in comparing what happened to the variance components, relative to the smushed model, I picked up another full % of my random intercept variance being explained. So the problem with the smushing is that in the previous model, let me put this table up here, the previous model said that both the within and the between were that same 0.012. But in reality, the between slope is 7 times as big. So we're not allowing enough of the level 2 contribution if you smush it together. It's the level 2 model that's going to be screwed up. So we hadn't looked at this yet, but now you know what we're going to see. If I add a random effect of my if I add a random effect of my time varying predictor. So U1 as the new term here. So time varying X goes in the fixed part and the random part. And time varying X and person mean X are still in the fixed part, and time varying X goes in the random part. Let's do one review question. If I add a random slope of my level 1 predictor, how many parameters have I added to my model? One vote for 2. Another vote for 2. 2 it is. What's the second one that's less obvious? Yep, the covariance with the intercept. So every time you add a random slope, you're adding a covariance with the random effects that were already there, or at least you should be. In our Elmer, that happens implicitly. That's a default. I'm not even sure how to override it, and I'm not sure that I would want to. It automatically puts in the covariances among all random effects at the same level, and it outputs them as correlations. In Stata, you have to add that with this covariance UN option. And that is an unstructured G matrix specifically that it's referring to. So the random effect variances and covariances get to be unstructured whatever they want. That is also not a default in SAS. You have to add that. So I have the two random effects solutions from the current model using constant centering versus the model using within person negative mood instead. And you'll note that they're not the same. These are not the same numbers, and there's no way to make them the same numbers. They're close, but they're not the same. In this particular data set, I did not have a random slope in the population model. So it's coming up with a number that's very close to 0 because that is the right answer. In real data, these numbers can be off by a much bigger amount. Do you remember why they're off from each other? Which of these is okay? The constant centered random slope or the person mean centered random slope?
The person mean centered one.
Yes, it
One.
is. That's the one that's not smushed. So what happens is this one is usually going to be, I think, smaller to the extent that there's no intercept heterogeneity. That's going to drag it down from what it should be if it's not a smushed effect. So this is the correct one. And this is shown here only for the purposes of illustration. In this data set, it doesn't make much difference, but it does in other places. Last model then, adding moderation effects by gender. So we have time varying negative mood. I have added the cross-level interaction with gender. I've added the between level interaction with gender. So person mean negative mood by gender as well, and the main effect. And so then what this model is going to tell me is the extent to which the within effect varies by gender and the extent to which the contextual effect varies by gender. There we go. So the pattern then, these two effects right here are specific to men, zooming in so you can see the numbers a little better, and they are within and contextual. So the way I would talk about this is, in men, 0.03 is the level 1 coefficient. For every unit grumpier I am than I usually am, my glucose the next morning goes up by 0.03 in men. After controlling for how grumpy I am today, how grumpy I usually am has a coefficient of 0.15. So for every unit grumpier I am than other people, my mean glucose goes up by 0.15 after controlling for how grumpy I am today. And if I want just what is the effect of person mean glucose altogether, I add those two numbers together. That's the total between, within plus contextual. In terms of the interactions, the time varying coefficient here has an interaction with gender that allows gender differences in the within slope. So that's the same exact result that we got out of the previous model using person mean centering because they're equivalent at level 1. The difference is at level 2. So this is the contextual effect in men. This describes how much smaller the contextual effect is in women. And if I wanted to figure out what the between effect is for gender differences in the between effect, I'd have to add those two coefficients together as well. This one happens to be significant, but what if it weren't here? Temporarily delete it. Actually, no, I'm not going to do that. I'm going to cross it out. 1 second. There. What if I did that? Is my model still okay, or is it a problem?
Is that also kind of smushing?
Yep. Without this interaction, this cross-level interaction between level 2 gender and level 1 negative mood is smushed. What it says is that the within slope varies by gender to the same extent that the between slope varies by gender. Smushed interaction. So we need the contextual interaction to unsmush the cross-level interaction. So take home message, anytime you want to stick a constant centered level 1 predictor in an interaction, stick the level 2 part in an interaction as well. Then you're okay. Here's the rest of all of the output, trying to recreate everything that we saw from the other model. And here's the change in our square, which gets us up to the exact same point as the other model as well. Then I made a picture. See if I can get it on the screen. There we go. Here's my picture. This is a different picture than I made before because I wanted to put the contextual effect on there. So previously, when I was describing the results of person mean centering, the x-axis that I had markers of less than usual, usual, and more than usual. And those only have meaning in a relative within person sense. I have changed the x-axis to be absolute in this case. Not absolute value, but like original value. So I have negative mood scores for the time varying predictor ranging from -2 to 2, and then I have plotted different kinds of people. So like for instance, the happy man here in blue dashed lines has a person mean mood of -1. So -2 would be less than usual. Usual would be -1, and 0 would be more than usual. The grumpy man, so the blue solid line here, has a person mean mood of +1. So less than usual would be 0, usual would be 1, and greater than usual would be 2. Okay, with me so far on the setup of this? So the contextual effect is the vertical distance at the same absolute level of daily negative mood, the difference between different kinds of people. The between effect is the slope of the dashed line through the person means, and here I've only drawn it for the blue people since they had the bigger effect. So after controlling for your actual value of daily negative mood, what is the incremental effect of being a grumpy person? That's what we're looking at. And in this case, the coefficients are both in the same direction, but there's a bigger between effect than there is within effect. So it's like how grumpy you are the rest of the days matters incrementally, not just how grumpy you are today. What a plot would look like if I didn't need a contextual effect is the last slide that I stuck in here. There it was. This picture on the top. That's what it would look like if I didn't need a contextual effect. Then all the lines kind of follow the same trajectory and there's not much vertical distance between different kinds of people. That rarely happens in longitudinal data. Could happen a little bit more often in clustered, but still not likely. All right, the end. Nope, not the end. Psych, M+ code. It used to be the end of this handout, and I added this stuff too. So in this version of M+, this is a precursor to what we'll do next week. I have time varying negative mood as my observed level 1 predictor. So absolutely everything is interpreted the exact same way because I am using observed predictors the same as I did in Elmer and in Stata. This model is set up to give me within effects at level 1, contextual effects at level 2, and all of the moderation by gender would apply to those two terms. Model constraint can be used to create new linear combinations of fixed effects and or variance components, and it can also be used to constrain parameters to make them cooperate in difficult models. So this is not an advantage relative to doing it the other way. I note that we're using maximum likelihood in M+ rather than REML, so that would actually be a disadvantage. The reason to change to M+ would be to eliminate the need for observed variables on the X side and to instead use latent variables. That's called latent centering, and that's what we're doing next week. And what I expect many of you may end up doing in your projects. Right, Carl? Isn't it fun? Yeah. He's knee-deep in latent centering right now.
Yeah, I'm looking at this and being like, so I don't have to do this, right? I don't
Correct.
have to do this thing, you know, like I just have to keep repeating that to myself.
No, I'm trying to
make
give
sure I'm not
like
crazy.
I'm trying to give as many as possible examples as possible as how to do things across packages. The only reason that anyone would want to do this in M+ instead of Stata Do you remember what it is? I said it last time. There's one reason. To fit the same exact model, but to do it in M+ instead. Missing data. I can take these observed predictors, bring them into the likelihood, basically fit an empty model for each of them, and then I can have missing data. Yeah, that's the only reason that you would need to do this in M+. Those of you who have clustered samples, like if you need to apply a clustered sampling correction, you can do that in Stata. I don't know what the options are in Elmer and R, or if you'd have to use a different package, but you can also do that in M+. So there's very few things that you would need to do with respect to observed variables. The reason to change over is really the multivariate case, where you're treating it as latent instead. All right, any questions before we call it a week? All right, then you can practice with homework 3. Let me know if you need anything with respect to your projects or otherwise, and thanks for being here. I hope to see you in person next week. Hooray! Or tomorrow if you're on campus. So, bye, folks.